Hello, dear students. I am Samir Velankar. I welcome all of you to this next video on pointers. Actually, this is just the continuation of the previous video in which we saw how to create array using malloc. I have still kept that slide ready over here. This was exactly the program we saw in the previous video. Just a demonstration of that program using Atom software, and exactly the same program has been written with pointer p declared and n, variable n of type int. We are asking user to enter the size of the array. Size of the array entered is n. Let's say we enter n as 5 from the keyboard. Then this statement will allocate memory required by size of one int. So it will allocate 2 bytes. But actually we don't want 2 bytes, but we want n into 2 bytes, because the user is interested in storing n integers, and size of one integer when multiplied with n will exactly give us the memory required to store n integers. So the expression should be allocate memory required by one int, that is 2 bytes, maybe 2 bytes. We are assuming that memory consumed is 2 bytes by one int multiplied by n. I hope you understand. So this particular statement is going to allocate an array. This int asterisk, everybody knows, is a casting done because the left hand side is an int pointer. So coming back to this slide, you recall I purposely made a mistake here in the previous video where we have to multiply the size of int with n so that we allocate n integers. Then p was pointing to a list of n integers, assuming that n is 5 entered through keyboard. Then if the base address is 100, p is going to store 100, and 100, 101, 102, 103, 104, 105, 106, 107, and 108, 109 will be the position of the last integer, indexes being 0 to 0 to 4. And at the end of the program, we saw how to free the array, how to release this array by simply calling free p. So all these statements have been written in the program just to demonstrate. And here in this section, we are entering the values of the array, isn't it? Using p plus I. Now recall p plus I is actually same as ampersand pi. Stick to the rules. Whenever pointer is added to I integer, then it is same as p square bracket I, and as we have not put asterisk before this p plus I, it is address, so it is and pi. Also in the next part we saw how to print the value stored. So here we are printing the values by using notation asterisk bracket p plus I. Recall that asterisk p plus I is same as pi. Now, whenever you write p square bracket I, it is simply replaced with asterisk p plus I. Then we are releasing the array, we are returning the array, we are announcing we don't want that array anymore, or we rather don't want that bytes anymore by calling free p, and that's the end of the program. So let's try to run this code just as a confirmation that we can allocate array dynamically using pointer. By the way, in this example, we have created int array. Any such array of any size, maybe float array or double array, or even array of structures can be created by using malloc. I'll just increase the font here. 5, n is 5. Then the malloc statement will create the array and ask the user to enter the values. If I enter 2, 3, 4, 5, 6, that's exactly 5 values. And the values stored were printed. So the array was genuinely created. By the way, towards the end of the program, the array has been destroyed by calling free p. But actually, free p, even when not called, will still free the array. So here calling free is very funny in this program, because anyway, after free p, return 0 is written and end of the program. So whenever a program ends, Whatever resources you are using in the program are anyway freed. This free P would be interesting if you write it somewhere in between the program and the program continues for the rest of many lines. Then it is always a good programmer's practice to free the memory which you are not using. See, we have to use memory efficiently. That we will see in data structures subject. Data structures is all about using memory efficiently and use the memory only if you need it. So if you don't need memory anymore, it's better to return the memory back to operating system. Before I end this discussion, something really interesting that we saw in earlier video also. If you hate this notation p plus I, pointer notation, you can still stick to and pi. You can write this. You never declared an array, isn't it? Look what you declared. You declared a pointer. And now pointer is pointing to list of n integers. So you can still use it as an array notation by writing and pi. Listen, and pi is anyway going to get converted into p plus I. And nice thing about this also is that if you hate this notation, asterisk p plus I, then you can still write this as pi. You are printing ith element of the array, where this will be converted anyway into asterisk bracket p plus I. I hope you are getting very used to the notations of pointers and array, as your teacher is repeatedly again and again telling you the same fundamentals and bombarding those fundamentals on you. Let's confirm by running this code, and it still runs. Although I have used p as an array subscript, it still runs, and there won't be any complaint made, because and pi is converted into p plus I and asterisk p plus I is converted into pi. So let's enter 5 elements again, 2, 3, 4, 5, 6, and that's it. It still works. So I hope you have again gone through the demonstration very well and you have no problem whatsoever in creating array dynamically. Thank you very much.